welcome to New York City Atheists live on tape, brought to you by New York City Atheists Incorporated. I'm your host, Dennis Horvitz, the David Letterman of the Hopelessly Damned. Several years. President Obama has lifted many of the bans on stem cell research done by federally supported laboratories, but not only has the United States, and it holds great promise for many diseases and conditions such as diabetes, Alzheimer's, and even heart disease. And it can be involved in rebuilding hearts. But that's not the only, the migration of jobs is not the only problem. Are migrating to these countries. Regenerative medicine basically focuses on stem cell cures, and it holds great promise for many diseases and conditions such as diabetes, Alzheimer's, and even heart disease. And it can be involved in rebuilding hearts. But that's not the only, the migration of jobs is not the only problem. We have what are called, what so-called ethical considerations. There are many religious organizations that oppose the use of stem cells, probably in some cases because of very honestly held beliefs, but I'm sure in a lot of cases it's because of their specific religious agenda that they wish to impose on the general public. So one of the ethical considerations that I think we should be considering is the fact that there's a lag in science education in the United States. So here today to address this issue, possibly pose some possible solutions, is Dr. J. Peter GERGEN, who is a professor in the Department of Biochemistry and Cell Biology and director of the Center for Developmental Genetics at Stony Brook University. And he has a list of credentials longer than my excuses for not having any. He is a graduate of the Massachusetts Institute of Technology. He has earned his PhD at Brandeis University. He did his postdoctoral work in developmental genetics under a Nobel Prize winner, and he told me how to pronounce his name, and I'm going to blow it. Eric Weishaupt. Is that correct? No. He will correct me when I... Weishaupt. Eric Weishaupt, who is famous for his work on fruit flies. In any case, before I ruin this introduction any further, please welcome Dr. J. Peter GERGEN.
Okay, so where are we now? I think everybody believes, even the people that don't want to do this, that there's potential for stem cell therapies. We've learned a lot about stem cell biology over the last 150 years, but there's a lot more to learn, and especially in terms of the similarities and the differences between adult and human embryonic stem cells. What can we do with each of these two cell types? What are the pluses and minuses? In terms of therapies, what are the advantages and disadvantages of different sources of these stem cells? It's definitely an exciting time. As I said, I've never seen any field of biology move as quickly as this one has over the last 10 years or so. That it's an exciting time. There are ethical issues. I think the conversation I was having before brunch with a few other people, an ethical issue we're going to have to confront in the near future is if everybody's living to be 120, then maybe retiring at 55 is not such a good idea. Right? There's going to be, in terms of the age of the population and what we're doing, there's going to need to be some changes in the way that we do things. And so there's going to be ethical issues. There are already, and these are issues that need to be confronted by an educated public. There's a lot of information out there. I think two of the best websites, I put these up here, that especially I'll tout this one, the International Society for Stem Cell Research, and I have some flyers from the society if anybody's interested. This is a really good website. It was one that was created by scientists that were pro-stem cell research, but what they wanted to do from the beginning was to try and have this be a balanced view, where they would allow viewpoints from the other side to make their case, and where one of the tabs is ethics. You can just go and read different ethical viewpoints. You can go and read what do rabbis think about this, what do Tibetan monks think about this. This one has a balanced view, and it's one of the more up-to-date ones. Again, things are moving so fast that I don't know that anybody has the money to pay the number of webmasters that you need to make sure that you kept on top of absolutely everything that was happening. But this is, for anybody that wanted to learn more, this is a really, really good website. Okay, so with that, that's my last slide, and I'll be happy to take any questions.
Great.
As usual, another great presentation. I actually just have a question first before I open it. You know, as I said in the introduction, the Obama administration has lifted a lot of restrictions. Do you see any foreseeable in the foreseeable future stumbling blocks that may, you know, get in the way of the progress that seems to be?
You mean a political or scientific?
Right. So one of the things that
Either,
there's always going to be scientific stumbling blocks, things that people have to get over. So one of the things that was sort of implicit when I talked about all the ways of getting around embryos is that when people realize that the potential of cells that can divide and that you can control their differentiation, that there's this field of regenerative medicine that's possible, that scientists tried to think of all these different ways to get around the roadblock of having to kill embryos. And so there potentially will be roadblocks. I think the potential for therapeutics is big enough here that there will be people that try to figure out how to get around them, whether that moves me moving to Singapore or building another lab down the street. Is depends on what the roadblock is.
Right. Well, I'm just the reason I ask that is because I don't know. You seem to be under the impression that these stumbling blocks are about facts, but we're atheists, so we deal with people who aren't interested in the facts in any way, shape, or form. So when you have a religious point of view, the fact that you may have very eloquently and specifically have explained why. You know, a certain procedure has nothing really to do with generating a human life or inhibiting human life. These people generally don't want to know about that kind of thing anyway.
Right. So that my answer to that would be the reason why I'm here, which is the last slide. These times need an educated public, and that's why when people ask me to give this talk, I've never said no.
Right.
I did ask Ken to explain a little bit about the goal here, but. And I teach this course to undergraduates at Stony Brook because I hope that every year, if I continue to try and educate people, that we'll get to the point where there's more people that are trying to deal with the facts. I will. There are. So the federal government has eased its restrictions somewhat. Scientists are pretty sensitive about this. I mean, maybe there's the occasional really crazy guy that wants to go off and do something really devious on his own. But anybody that's doing biomedical research at any institution in the United States that gets a penny from the federal government, there are committees that if you want to do things with vertebrate embryos, you have to write out exactly what you're going to do, how many frogs are you going to use, what are you going to do with them, what are you going to do to alleviate pain and suffering. And there's a committee that reviews that has to approve it, and that committee always includes at least one layperson, somebody that's not part of the university. And so people are trying to be careful. All that said, there are 3 states, and I won't name them, but you can probably guess what color they are, that said, well, the federal government has eased its restrictions, but we're not. That we're not going to allow you to do that here. And that's so that for people that want to do stem cell research, there are now 3 states that the university medical centers in those states are going to lose some of their best scientists to go to other states.
Must be the will of God. Also, let me say, please try to keep your questions as short as possible because we want to get everybody in. Right now.
Yes, I teach the same subjects that you do. I teach physiology and also environmental science. The most difficult question that I have to deal with and I pose to you is, what do you do when this enables the population of the Earth to just expand and expand and expand because people's longevity is just extended immensely by the fact that they now can replace so many different parts that wear out? And I try to deal with this, especially with my environmental science students, and they're horrified because I tell them on planet Earth are like we're sailing on the Titanic heading for an iceberg. And honestly, it scares the shit out of them, pardon my French here. And I don't have good answers for them. I tell them, you come up with answers. You tell me that you're not going to reproduce and have any children, or only one child, like they do in China. Come up with some ideas, because unless we do, the miracles of modern science are going to just extend life so much that the population explosion will occur even faster.
Yeah, I mean, that's why I raised that at the end. That's ethically, that's a different ethical issue from destroying embryos. But for the human population on this earth, that is equally as important an ethical issue. And yeah, you know, do we create death panels and say, okay, you've replaced enough body parts, you're done. You had your 5 chicks.
I touched on the subject with death lotteries with my students, and I got girls screaming.
What's a death?
Horror! What's a death lottery? Yeah. It's like you have a ticket to the lottery, except if you draw a lucky number, what you have to do is make arrangements to take a dose of sleeping pills.
The short story, the lottery?
Yes, yes.
By the way, Howard, I'd like to say I really like the fact that you did throw the question back onto those students. It keeps you.
So at the end of the day, I mean, I'm an optimist, and scientists are exploring the technologies to see what is possible, what can be done, and then it's up to people that are making decisions about what ethically is allowed to decide what you can do and what you can't do. We could go, when I was in 2nd grade in Bethesda, Maryland, I remember being trotted out into the hall and putting my head between my knees in the preparation for nuclear war. Right? You know, that didn't happen, and that's hope. You know, hopefully,
cover. I think they call that, right?
Hopefully, we can be smart enough.
Excuse me, with aging being a known fact, and as we get older, the aging process seems to be pushed further and further up, right? So at what point are we going to reach when it is the regenerative process is not practical? So do you tell so-and-so, XYZ, you're too old already for regenerative when they want it? So we're going to have to face that. Maybe it might be 100. Maybe we can keep regenerating, and then after 100, then maybe it'll be 120. I don't know. Have we faced that kind of a question?
I don't think we're facing it yet, but I think it's not too far down the pike. And right now, based on what we know about sort of human biology and the senescence of cells, at some point they just don't want to keep going. That right now, until we figure out how to reprogram senescence, it's probably around 120. And that's, you'll see that the oldest people in the world, it's about 120, is you know, in Guinness. And then, oh, there's somebody that's 119.
Right, we have people living to 100, and who's to say to anybody, you're too old, so we can't give you regenerative cells to replace your arm, your skin, your burned, or whatever it is.
Which, so another ethical issue here is, so maybe somebody can live to be 120, but what's their quality of life? Right? They're just a bunch of cells on a mattress that you have in your body.
Well, we're doing that now with tubes and all kinds of things already.
So, you know, that's I can't answer that. It's
no, right.
I do. Well, one question does tie into the whole question of aging, because there's a lot of research going on aging, and they used to think that aging in cells was caused by telomeres, on, you know, shrinking or whatever, and now, you know, they're starting to say that it's not the telomeres, that it's something else. So I just wonder if you could comment on that. But the other thing I was going to ask you about was that we've spoken about regenerative and curative. What about enhancements? I mean, what about enhancements to brain function? What about making people more intelligent? Is the military involved in this? You know, making people run faster, or, you know, improving people's reflexes, shortening the nerve transmission times or whatever. Is there any, you know, does it hold potential for that, and what are the ethical implications of?
So the ethical implications are enormous, and there's lots of technologies that are out there. Right now, where we're going with human genetics is that the ability to sequence DNA is such that, so the Human Genome Project, that was a huge thing when that was done in 2001, that you know, here a whole human genome is decoded. It's now approaching the point where it's almost cost effective that if a patient walks into a doctor's office, that the doctor can just take a sample and get the entire sequence of that person. which now you could go and look for all the genetic predispositions. What is the genotype of this person? Do I tell the insurance company what I know about the
Yeah,
genotype of
that's
this
the whole
person?
thing.
That, you know, the potential is there to radically change how we do medicine, which, okay, is it enhancement or is it recovery? Where do you draw the line there? That's clearly an ethical issue. There are things we can do now with growth hormone. That if you wanted to have the middle linebacker at the University of Texas, and you could find a doctor that was willing to give you the stuff that you needed, you could probably have the linebacker at the middle of the University of Texas by treating your kid at the right stages with the right stuff. Most people don't do that.
Right. Bob and then Joe.
Let's have another
Bob, right.
Kind of a more sociological question about education. From your perspective as a professor at Stony Brook, what kind of students do you see coming in to your classes? And do you find opposition, say, from practicing Catholics or Orthodox Jews or Muslims to what's going on either in your classes or the university? And also there's been much discussion about how science, especially postgraduate programs, are heavily dependent on countries like China and India, Asia to supply their doctoral students. Is that true at Stony Brook, or whatever observations you have on this?
Right, so I'll comment on both of those. The thing that I've seen with the Stony Brook students is, so I've been teaching this class since 2001 on embryonic stem cells and stem cell research. And I'd say the first couple of years there were maybe a couple of students that, you know, I would try to encourage an environment where people would speak their views. That there would be a couple of students that would say, you know, I think this isn't good that we're killing babies to do this. I'd say in the last 5 years, it's almost unanimous every class that they want to understand what it is that's going on, but that this is something they're for and they can't believe. Remind you, this is the State University of New York. New York is one of the bluer states. Stony Brook as a public university, we've done pretty well because we're relatively inexpensive, that it's become more and more competitive, so we're getting, I think, better quality students, especially in the recent economy. And it's a student population that's very diverse, that we have a lot of first-generation immigrants, so there will be Muslim kids and Hindi kids and Catholics and Jews all in the same room, but we're this generation. They all have the best cell phone in the world. They all can IM at the speed of light, and they're all pretty much in favor of, you know, technology is a good thing. I want to understand it so that I can. But you know, that's you know, if you were to go to a university somewhere in the deep south that was a private institution, you might find it slightly. You probably would find it slightly different. So that was one question. The second. Was in terms of...
You just wondering about graduate students. Do you
Yeah,
find
so
them
graduate
American
students...
trained or foreign trained?
So it depends on... Scientists, what I learned at MIT, we think about things in sort of a reductionist way, that math is the tool that you use at all levels. Physics is the bottom, chemistry, biology, and then, you know, psychology, neurobiology up at the top. The harder the science, so physics already has been predominantly, even at the very best graduate schools in America, it's mostly foreign students, because physics, and there's Keith Shepard when he comes and talks in a couple of weeks, I'll tell one of his stories now, don't tell him that I told you this, but it's, in terms of the way we teach science in America, this is an anecdote that he'll tell you, that so the typical thing, I don't know how many of you had kids that have gone through the public schools or the private schools, 8th grade earth science, 9th grade biology, 10th grade chemistry, 11th grade. So you step through this stuff. The course that it's possible to go through high school and not take is physics. Mm-hmm. Only kids that are in 12th grade that really like science, that are going to do AP physics, take physics. That's from the scientific viewpoint, that's the foundation upon which everything else is built. The story he'll tell you is you go to a foreign language department and tell the chair of foreign language, okay, I want you to do French in 9th grade, German in 10th grade, Italian in 11th grade, and then the kids that do all of those, they can take Spanish, AP Spanish in 12th grade. But you're not going to learn anything doing it that way. And that's right now the way we teach science. This is this jumping around rather than some sort of integrated, looking at things holistically. Let's use the tools and study.
So in general, you would find your undergraduates that are American trained.
The Stony Brook undergraduates are very diverse. The graduate students in physics, I'd say they've been foreign for 10 years. Right now, at Stony Brook, biology, the biomedical sciences, it's about 50-50 foreign versus domestic.
Graduate or undergraduate?
That's graduate students.
Graduate.
And you go to psychology, there'd be more domestic because that's a little further up. Chemistry is sort of in between physics and biology.
Joe?
Yeah, I know that there's a campaign, I don't know if this is related at all, but I know that there's a campaign for mothers to save cord blood from their newborns. And I was wondering, is that so that, is this related to that?
Yes, yeah. So that would be the idea that, mothers that are going to save cord blood from, so you have a baby, is there something we could capture that would give us a source of stem cells that we could treat that person with for the rest of their life, that we could put in a freezer, they come back 20 years later, they've been in a car wreck and they've got a problem, that you go to the freezer and say, okay, here's the cord blood that was from this person. What cord blood has in it? We know that there's hematopoietic stem cells. We know there's some other cells that are, they're not embryonic stem cells, but they're back closer to the beginning of development. And with the induced pluripotent stem cells now, it may be that you don't need to do that. So one of the issues with treatments with induced pluripotent stem cells right now is that the trick so you take the cell out of somebody, a fibroblast cell, you put in the 4 genes, you culture it for a while. It takes a couple months before you've got the cell line, that's the induced pluripotent stem cells, and then you have to take those and you have to get them to do figure out how to culture them to grow some kidney or some liver or whatever. So you're talking about 4 or 5 months. If somebody's got an acute problem, maybe you don't have 4 or 5 months to go and regenerate that tissue that you need to repair something. Because that's where the idea of having a repository, and so if we could get the single cell biopsy to go well, then maybe everybody would go and before the embryo is implanted, let's go take a cell out and freeze it away so that we've got embryonic stem cells from that individual.
Someone who hasn't asked a question. Gentleman in the back. Go ahead, get right in the back.
I understand that the most fertile ground to collect embryos for stem cell research is actually the IV in vitro fertilization banks, right? My question is, every time an IVF attempt is done, at least, let's say 4 out of 6 embryos are wasted, and if those embryos are going to go into the garbage anyway, how did the Bush administration actually block the continuation of stem cell research if those embryos are actually weren't going to be viable? We're talking about embryos that,
Right. So that is a very good point, and I'd say that in my...
I'm sorry, what then is the ethical issue?
Right.
These embryos are going to be destroyed in any case.
Right.
And,
So I'll answer that.
Sure.
So this is a very good point. That there's a logical inconsistency that I'll come back to in a minute. That all of my undergraduates have realized that right now you're just throwing them out. Why don't you use them for something good? That those people that are opposed to doing anything with embryonic stem cells, to be logically consistent, have to be opposed to in vitro fertilization. They have to say, we should not allow in vitro fertilization. Once you allow in vitro fertilization to happen, then you're creating something that you're going to throw out. Unless you're going to go to California and put all of the oocytes into some poor woman that's already got 6 kids.
I remember a situation, maybe the last 15 years, this woman out in the West Coast wound up having in vitro and had 8 kids or something like that. I'm not talking about the octomom, I'm talking about even before, like maybe 15 years ago, and basically wound up being on the public dole because of it. Organizations were donating money to her, but basically what this couple said was, we had the in vitro, fertilization, and we left it up to God. Which, if they had left it up to God, they wouldn't have had any children, basically. That's the logical implication of what they say. Someone has, yes, this lady right here.
3 sort of related questions. What percentage of the funding in this area now is public versus private? What are the leading centres for research in the world? And how far did the US fall behind because of the Bush prescription, and can we catch up?
Right. So I can't give you an accurate assessment of private versus what the percent of funding is. I think there's quite a lot of money being invested, both privately and publicly. The leading centers. So if you were to go and look through, I leaf through these on the train ride in. If I go through the press releases that I've seen in the last 2 months for things that have been done, even now with the ban lifted and with the IPS stuff that is a little bit more wide open, that England, Japan, Singapore, and then in the United States, this institute in Boston that the Juvenile Diabetes Foundation runs, and then California. A lot of the work right now is, California said we're going to do it, and then it took them about 5 years to get through the courts where they could actually start spending the money. But there's an Institute for Stem Cell Research in California that is doing cutting-edge stuff that's maybe a little bit behind the guys in Japan, but they're right there. Will we catch up? Yeah, we'll catch up.
Two more questions. Someone who hasn't asked
If
a
we
question.
start educating, giving physics to the 8th graders.
Adding to that, how are they doing at the University of Wisconsin on stem cell research?
They're still, it's a big place. I think they may have had some people leave. I'm not sure exactly, but it's a very, very good school. And
For stem cell, because I gave them a lot of money, that's why I want to know.
it's a very good school that I think is doing
Good
well.
work on stem cells, thank you.
If we've got any more questions, I'll take your. I'm sorry.
Okay. Yeah, not to be critical, because I really appreciate everything that you've done here. You mentioned in the beginning of 2001 when I guess Bush made the statement that we should have a cooling off period, or
Right.
whatever you want to call it. And I just didn't understand exactly what would that do, or what would be the adverse effect of having a lot of federal funding in this area from your point of view, and I don't mean it as an attack.
Right, so the cooling off period, there was one other, in my life as a scientist, there was one other era where I saw a similar thing happen, and that was when recombinant DNA technology exploded, and people realized that you could take DNA from a mouse and put it into a bacteria, and you could mix it with DNA from a virus or DNA from a man, that you could make novel DNA molecules. Maybe we could do, so there was, okay, we can do all this stuff, what should we be doing? There's one of the leading scientists that was involved in that, Herbert Boyer at Stanford, headed up a commission. So they said, okay, no more recombinant DNA work for a little while. They got together a bunch of scientists and ethicists from all over the country to say, with the NIH, National Institute of Health funded research, these are the guidelines, that if you're doing this level of mixing DNA, then this is what you need to do as a precaution. If you're doing this, it's a little bit more dangerous.